Hi everyone, I'm Yegor from the Gravity Engraving channel, all about laser machines and markers. Today, a quick look at a 200-watt jewelry laser welder. It pulls 7 kilowatts, it's got a microscope, display, camera, dual lights, stop button, and key. Up top is the ignition block, which I've shown before. Below is the passive cooling system, though there's room for a compressor and a proper chiller. Jewelry welder. So the chiller, it had a Chinese plug, but I wired it directly to the mains because of the high power draw. Looking at the back, there's just the main breaker, remember to turn it off, and the filler neck. It's a 10-liter tank with 3 more in the system. Note that you'll remove this cover often to connect the pedal or the rotary axis. On the other side, we have the radiator unit for the passive cooling output. Rotary, the control board, power supply, and the stepper motor driver. I have no idea what this output is for, this little connector right here. Then we have the water sensors and a separate one for the rotary axis pedal. It'll also be used for the signal output pedal. It's all pretty straightforward. Moving to the front, even a rhino would be impressed by this welder. This contraption here is to keep sparks and debris inside instead of flying out. There are definitely pros and cons. One pro is the fully enclosed chamber. There are armrests and a separate air supply. The air connects on the same side as the main power switch. There is a joystick to control It's convenient, I gotta say. Great design. It's a 5-way joystick plus an e-stop and 2 lights. There's the spotlighting you see now, and another light right on the camera or the optics. So yeah, everything here seems pretty simple and easy to understand. Next, the display, the key, and power on. Let's fire it up and see how it looks inside. Shouldn't be any issues. Release the stop button, turn the key, and it's on. 7 kilowatts is quite a lot. The display boots up and everything here is very simple. We have our microscope, the magnification is high enough to see a fly's backside. Once the system is ready, we hit on to start charging the capacitors. Energy builds up, and then we can set the power, the pulse duration in milliseconds, and the frequency range for each pulse. Then there's the focus, which lets us adjust the focal distance, meaning we can change the spot size. This happens right here in the galvo head. 142. That was done yesterday during testing. So doing 1,000 pulses in 5 minutes during tests, oh, our capacitor's charged. Doing 1,000 pulses in 5 minutes is no problem at all. Okay, state is standby. Pre-combustion, hard to say, but whatever. And we can start now and run a couple of tests. I'll be doing tests on stainless steel. Power, I'll say it again, is 5%. We don't need any more than that. For stainless steel, it's actually more than enough. Let's do a test specifically on the rotary axis. We set the required focal distance. Checking so we don't burn our fingers or anything else here. Unfortunately, I'm trying to catch where I am right now. There. So our task is as simple as possible. Bring the token to the right height, the right level. Click a couple of times on one side, a couple of times on the other using the pedal. Right? And now just go ahead and flip it over. Okay, that's it. You're done. The second side as well. We clamp it and break our first via. Yeah, I'm gonna be fumbling around a bit now. I tested it yesterday and I liked everything. But it takes more time, more experience to work on a machine like this. There, that's enough. That's enough, actually. Honestly, I think that's really all we need, you know? This takes skill. Move. Again, we're holding all this by hand, it's a bit awkward for doing pretty work. We'll do a simple test now, nothing fancy, and here we go. No, not enough. There, that's it. And with smooth movements, we click one after another, welding our seam. Let's change the pulse duration to 2 now. I'll increase the frequency to 10. Oh, power. I'll increase the frequency to 10. So for frequency, we can press and set it, like this. Enter. The facula is fine with us. Facula. Yeah, Umencula has a big facula. Okay, let's go. We'll give ourselves some room to move right away, practicing the movement of our token. Setting the value to 6. We can't even weld it yet. Let's do the same on the other side. Everything is processed quickly, as efficiently as possible. The only thing is, yeah, you must supply air to the processing zone. Alright, let's get to work. That's it. I don't have enough hands. Not enough hands for 50 millimeters. See the final result. Now let's take a quick look at the final result of our work on the stainless steel. Work on stainless steel. Yeah, without a table we did it all crooked, but what can you do? In principle it's pretty good, both on one side, and we'll have the same thing done on the other side. Let's spread it a bit. Breaking something like this is very difficult. I'll try to explain how the rotary system works here. In principle it's pretty good, both on one side and on ours. The same thing will be done on the other side. Let's turn it a little bit. Breaking something like this is very difficult, as you can imagine. Because of its strong construction and the way it's built, it really takes a lot of effort and force to actually break it. It doesn't work, axis. It doesn't work automatically. No specific angle, movement, or rotation is set. There's a separate rotary axis driver that can rotate with a number of pulses. There's a pedal with 2 presses. One is responsible for a full 360-degree turn, which we set up in advance. And there's this option. Right now we're just doing a pure test. I started the rotation, plus the signal. We made the hits. It's all off and crooked. There. But exactly 360 degrees, just as we discussed earlier. So the pulse, right where we had it before, is still set. We'll set the power and keep it exactly the same as it was previously. Keep the pulse milliseconds unchanged as well. Set the frequency range to 15, just like before. Press it again to confirm. The camera's going absolutely crazy, of course, as you can see. There you have it. Now let's lower the speed. It fires without stopping. The pipe is hot, I'm telling you now. But we welded it very cleanly. The main thing now is how you position it, how you set it up, how you'll continue welding. Let's do another one for practice. The seam will be untreated. Seam processing. The seam will be untreated. What don't I like here? I'm missing a button press to just rotate 360 degrees without starting. For this, we need to disable, at least from what I found, the laser signal and start its processing. Press the pedal. It rotates the pipe a full 360 degrees, and naturally I ended up cutting it with a grinder, so as a result it's all crooked and uneven. But somehow, even with that, it gets very close to the zone I need. Maybe, if I try turning the pipe a bit more, the situation will actually be better from the other side. Now Sigma, minus, we hit exactly where we needed to. One more time. Right here, what's currently missing is the signal feed that goes directly to this little machine, so we could weld it with pulses. It seems to match, and for the finale, we'll set the frequency range again, let's say 15 as well. There we go, everything's set, and let's go. Wrong pedal, of course. In a repeat. Let's take a quick look at the seam on the pipe. Basically, we got everything we wanted here. I'll loosen it a bit now, it's clamped too tight. All the pulses went through well. High quality, everything looks cool. Wonderful. Here, as I promised, nothing will weld. The gap was too big. In theory, yes, you could put some filler in and get a good final result, friends. Friends, this was Igor, Gravity Engraving Channel, a channel about laser machines and markers. Today, we had a welding machine with 200 watts of power. Its actual consumption is 7 kilowatts plus a rotary axis. There are many pros here, and there are also many cons. I won't talk about the cons for the main reason that no one shipped in for this machine, so accordingly, all those cons will stay with me. In the future, I will of course be tweaking and fixing things, maybe I'll make videos about it, and that's exactly the topic when I go to China and start telling the Chinese something, and I get the A big thumbs up from you. Wishing you all the best, lots of cash, and bye-bye everyone.